All right, it says Corey and Jeremy have ages that are consecutive odd integers. The product of their ages is 783. Which equation could be used to find Jeremy's age, J, if he is the younger man? Show your work. Okay, so consecutive odd integers. Let's think of a classic set of consecutive odd integers and then figure out like how we would find consecutive odd integers. So let's say number 1 is J, or the first consecutive odd integer. To get from J to the next odd integer, I would have to add 2. And then to get to the next one from there, I would have to add 2. So if you start with one odd integer and then you add 2 to that one, you will get the next consecutive odd integer. So if we have Jeremy as the younger man, let's let Jeremy's age equal J. So then Corey's age, therefore, will be J plus 2. So if we wanted to show the product of their ages is 783, we would have J times J plus 2 equals 783. So that would end up being choice 3. Number 2. The area of the rectangular playground enclosure is 550 square meters. So we have a rectangle. His area is 550. The length of the playground is double its width. This is the width. This is the length of the playground. Double means times 2. Write an equation that could be used to determine the dimensions of the playground. You do not need to solve. So I have area is equal to length times width. The area is 550. The length is 2W times W. 550 equals 2W squared. It says we don't need to solve, so that's it. Number 3, John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x equals 60 plus 5x. The total amount of money Sarah will save is given by the function g of x equals x squared plus 46. After how many weeks, x, will they have the same amount of money saved? Show your work algebraically. All right, so I've got, let's see, John's money. And that is going to be f of x equals 60 plus 5x. Then I got Sarah's money. That's going to be g of x equals x squared plus 46. When they have the same amount of money, it's where the graphs cross. Algebraically, if you're trying to show where two graphs cross, you're going to set them equal to each other. All right, now I'm just going to sort and get everything all on one side. This looks quadratic to me. I always want to try to keep the x squared positive, so I'm going to move everything from this side over to be with its friends over here. So I've got x squared, then 46 minus 60 is going to give me negative 14. And then I'm going to move the 5x over. And I now have x squared minus 5x minus 14 equals 0. This guy is factorable, so I'm going to do x. Let's see, I'm looking for the factors of 14 that add up to 5. That's going to be 7 and 2. And then the middle number is negative, so the bigger number is negative. There we go. Let's do our little t-chart to get our solutions. And I'm going to add 7 on both sides. And I'm going to subtract 2 on both sides. And these are our two solutions. After how many weeks, x, will they have the same amount of money? Okay, so we're talking about number of weeks, so we're going to reject the negative solution and take the positive. All right, number 3, Jaden and Adriana are each saving money for a car. The total amount of money Jaden will save is given by the function f of x equals 3x plus 10. The total amount of money Adriana will save is given by the function g of x equals x squared minus 30. Let's go ahead and write these down. And then Adriana. After how many weeks x will I have the same amount of money? Okay, this is like the exact same problem. It just has different numbers and different names, but it's the same. If we're trying to find the number of weeks X where they will have the same amount of money, all we do is make the two graphs cross. The way you algebraically make two graphs cross is you set them equal to each other. Let's try to keep the x squared positive, and we're going to sort everything on the left-hand side over to be with the right. All right, and now we have to solve it. This guy looks factorable. Sweet. Okay, so I'm looking for the factors of 40 that add up to 3. That's going to be 8 and 5. The middle number is negative, so that means that the bigger number has to be negative, and that's it. Let's set each factor equal to 0. Okay, and again, we're talking about number of weeks. Let's reject the negative solution and we will take the positive. X equals 8 weeks. The llama picture. A rectangular picture of a llama, measures 6 inches by 8 inches. Simon wants to build a wooden frame for the picture so that the framed picture takes up an area of 100 square inches on his wall. The pieces of wood that he uses to build the frame all have the same width. Oh, these dimensions are a little misleading here. It looks like the picture itself has dimensions of 6 and 8. Okay. The whole picture frame, though, like this whole thing, has an area of 100. Okay. The pieces of wood that he uses to build the frame all have the same width. It is an unknown width, but they all have the same width, right? They're all some unknown identical width. Let's label that X. Write an equation that could be used to determine the width of the pieces of wood for the frame. So if I know that it's this guy, the picture, right? He's 8, and then I need to tack on an X here and an X here. I should have the full length of this left-hand side. I want to do the same thing for the right? I have this length of the blue picture here. And then I got to tack on an X and tack on an X for the width of the picture frame. So this guy would be 6 plus 2X. So now I have the dimensions of the picture as a whole. Write an equation that could be used to determine the width of the pieces of wood for the frame Simon could create. So we have area is equal to length times width. The area of the whole picture is 100. The length of the whole picture is 6 plus 2x. And the width of the whole picture is 2x plus 8. All right, so that's our equation. Sweet. Solve the equation to determine the width of the pieces of wood used for the frame to the nearest tenth of an inch. So now I've got 2x plus 8 times 6 plus 2x equals 100. So what I'm going to want to do is distribute this guy to make sure I have everything multiplied out correctly. So I have a 2x plus 8, and then I have a 2x plus 6. So that's going to give me a 4x squared plus 16x plus 12x plus 48. So I now have 4x squared plus 28x plus 48 equals 100. I'm going to divide everything by 4. Just make everything a little easier, I think. There's 100 on this side. I got to move him over first. Get everything set equal to 0. All right, cool. 4x squared plus 28x minus 52 equals 0. Now I'm going to factor out a 4 from everything. And that's going to leave me with x squared plus 7x minus 13 equals 0. I'm going to go ahead and factor that guy. And that's going to be 13. Oh, the only factors of 13 are 1 and 13. So I'm definitely going to have to solve this guy with my calculator. He's not even factorable. That's okay. We can do that. Here we go. All right, I'm going to graph it and find the solutions. All right, I've got 4x squared plus 28x minus 52. And let's find those solutions. Okay. I've got x equals negative 8.525, x equals 1.525. Which one makes the most sense in the context of the problem? X represents the width of a picture frame, so we're going to reject the negative and accept the positive.